Welcome to Inspiring Minds, powered by the Edison Awards, where we showcase the leading innovators from across the globe. I'm your host, Jennifer Trammell. Today, we step into the world of materials science with Kennametal, a company founded on innovation. Materials science, engineering, product design, that's the core of what they do. Dr. Carlonda Reilly, Kennametal's Vice President and Chief Technology Officer, is with us to share the innovation that earned a Bronze Edison Award. Carlonda, welcome to Inspiring Minds.
Thank you for having us.
Well, great to have you here today. And I want to get started with making sure our listeners really understand Kennametal. Now, they may not have heard of Kennametal before, but they've probably encountered the products of your work. Tell us about that.
So Kennametal has been in business for about 86 years, and we are a global industrial technology leader. We operate in over 100 countries, and we have over 8,700 employees around the world. And what we do is we are working with customers in aerospace and defense, construction and mining, energy, general engineering, and transportation. So our tools and material solutions enable our customers to run their operations longer, to cut faster, and to machine with greater precision. So our tooling and wear solutions provide a high level of precision for cutting, running operations longer, and faster.
Can you give us just a basic rundown? What is material science?
What is material science? So it is a way to understand how to put a material together to solve a specific need. So our material science is based in primarily metal alloys, and tungsten carbide is one basic material that we work in. We work in other type of materials like our ceramic materials like boron nitride or boron carbide. And so what material science does is really help us understand on a fundamental level how those materials work, how they work in combination with other materials in order to make the type of properties that we need for the applications that we need. So if we need really tough, if we really need wear resistant, really high wear resistance, we know how to put those materials together. We know the formulation of those materials that we need. We know how to process those materials. We know how to do what we call sintering. We know how to actually lock those materials together in a way that provides the highest level of either cutting resistance or wear resistance that we need for our customers. And so that's in a nutshell how I can describe material science. It's really understanding those materials on a fundamental basis in order to know how to put them together in a way to meet the needs for our customers.
Well, congratulations to you and the team on this year's Bronze Edison Award. And we'd love to learn more about that metal cutting innovation and technology that earned the Edison.
Thank you very much. And we're very, very honored, and we'd like to thank the Edison Awards for this, for the recognition. Kennametal has been recognized with an Edison Award for its additive manufacture cutting tool design with Kennametal technology. And so Kennametal technology grew out of a specific customer need to provide efficient tooling for both internal combustion and electric vehicle component manufacturing. And as transportation components become increasingly more sophisticated and requirements more stringent, our manufacturers need complex tooling solutions to machine those components. And so in the case of Kennametal technology, one of our transportation customers came to us needing to optimize their machining processes for transmission housings. And so that's where our experts went to work to define a solution.
And some of those design ideas and inspiration came from nature, right?
Absolutely. So it's inspired by what you might find, some of the designs you might find in nature. For example, if you have a tree planted by water, that tree is going to survive in a way that it's going to be as optimal as possible. And so those roots are going to grow toward the water, and it's just a natural process. The root structure will evolve toward the water, and then that tree will grow to the largest extent. And so that's the same kind of concept when you're trying to design a tool like this. You're wanting to put the material exactly where you need it in order to make it as strong as possible. And it comes, we find out that we don't need the metal everywhere. We only need the metal where we need it in order to put the cutting instruments where we need it to do the operation.
What did your client think by the end of this innovation?
Oh, absolutely. So one of the things that we're able to do when we work with customers on our innovations is we have three global labs as well as 22 engineering hubs around the world. And so we were able to bring the solution back into one of our labs and demonstrate just how productive and just how effective and efficient this tool was. And they were very, very happy to see the performance demonstrated in our own labs, and they had the confidence to bring it in their own manufacturing facility. And we were able to prove it out internally here, and then take it to our customer and succeed in winning that business.
And this is part of your usual process, understanding problems that clients are facing, working through an innovative solution. Tell us more about that.
Yeah, the approach that we take at Kennametal um, is what we call customer-led innovation. So we have scientists and engineers out in the field with our sales teams, visiting customers, understanding their needs, and we work very closely with our customers to understand those needs. And then our science and technology folks that are out in the field can translate those needs into technical requirements. So we bring those challenges back to Kennametal, where we have a large organization, over 500 scientists and engineers globally, to work on various problems that our customers have. And we apply our material science, product engineering, application engineering, or process engineering to come up with the best solution for our customer.
It sounds like the team really likes those kinds of challenges.
It's what excites me every day.
Well, let's talk more about that. What do you love about coming to work at Kennametal?
So, what I've found at working at Kennametal is I work on the executive leadership team, and we work together to develop our strategy and our technology strategy. And so, I have the opportunity to lead that. And what's really exciting for me is that I also get to work with some of the best scientists and engineers in the world. And they're some of the top scientists and engineers in their field. And I really get excited when I go out and I talk to customers and I can see how our solutions are able to bring them solutions for their own problems. And we're able to deliver higher productivity, more efficient tools. We're able to develop solutions for them to make their components in ways that they couldn't before. And so it really excites me to work with some of the best people in the industry to bring solutions to our customers who are thrilled with what we're able to deliver to them.
We're here now at the end of this successful process around the Kineonic technology. Tell us more about kind of the nitty gritty when you're in the midst of this process, when things don't go according to plan. What does it take to keep the team going through and really demonstrating grit there?
Yeah, we work through a process. We have a stage gate process for which we work through our problems. And we get a lot of aggravation out early on in that stage gate process where we have all kinds of ideas and we're exploring those ideas. And then we can actually weed out the ideas that don't seem to be working as well as we want them to. So by the time we move a project from that kind of ideation stage to the development stage, we really have some some solid avenues in order to approach the technology and the solution. And so I think our processes really help us in weeding out some of those frustration points early on. And then it's not that we don't have some frustration points later on in those stages, but they're far fewer in between. And they're also more, we have more tools and more, I guess, science approaches to be able to tackle those, to move through them quickly. So we use the process very well to our own advantage in order to move products faster through our pipeline and to get them out to the market as quickly as we possibly can.
It sounds like innovation is really part of the DNA, the makeup of Kennametal.
I've always said that innovation is the lifeblood of any company, and that is certainly true for Kennametal. Innovation is the lifeblood of Kennametal, and that statement was true 86 years ago when the company was founded, and it's even truer today. And it's a very important part of our business strategies. Our innovation strategies really go to support our business strategies, to make sure that we can provide solutions to our customers and also continue to grow as a business.
Just out of curiosity, can we go back to the founding? So 86 years ago, what was the company like then? Why was it created? And tell us a little bit more about that evolution.
So our founder created the company because we needed solutions in with metal powders, and so we were founded on tungsten and tungsten powders for a variety of industries, and really it required a lot of material science. It required a lot of engineering, and so that is very present today, where we utilize material science, metallurgy, metallurgy, along with product design and engineering in order to develop a variety of solutions for very similar markets that we got started in 86 years ago.
Thanks. I was just curious, thinking back 86 years and what was needed then and how those needs have evolved. But it sounds like the foundation has really remained the same.
Yeah, I mean, if you the foundation of material science and engineering does remain the same, but the problems do evolve and they get more sophisticated over time of our customers, and so the applications evolve. The applications are different. For example, a commercial airliner, 50 years ago was very different than how we build commercial airliners today. So it does require different type of solutions. For example, we're going through the innovation of the transportation energy, going from internal combustion engines to hybrids to electric vehicles. The requirements and the different components that are required for that transition all the way to electric vehicles are very different. So they require different solutions, and it requires us to develop different solutions to be able to make and create those innovations. So, like I said, every bit of much of material science, the type of grades that are required today are different than were required, say even 20 years ago. And so we're continuing to evolve that science, evolve our understanding and our fundamentals in order to bring those new solutions. And then I don't want to neglect the importance of automation and digital tools in terms of being able to make our innovations as well. And we have a very large effort and what we call our smart factory effort in terms of the connectivity and the digital tools that we're bringing to bear to make our own innovations more effectively and efficiently for our customers.
It sounds like artificial intelligence would factor in here.
Absolutely. So we, in our smart factory efforts, we are developing a lot of data, and that require a lot of analytics. So we have data analytic engineers, and we take that data and we put it back into our own processes in order to figure out how can we optimize the process to make our own tools more efficiently. And so that's one way that we have really begun to transform how we make our products for our customers.
So, Carlonda, I've got to ask, what innovation is going to get you back to the Edison Awards next year?
We have a strong pipeline of products. Our technology organization works very closely with our marketing and sales organization. We're out with our customers, and we have a very rich pipeline that we're working on that brings new material science solutions. Some of that involves some of our basic solutions like tungsten carbide, but we also have businesses in ceramics, and we have new process technologies that we are implementing. And then we have a rich pipeline of new products that we deliver to the market. And so we just have to make sure that we're selecting some of our best efforts and maybe we'll bring a couple more to the Edison Awards in the coming years. And I think we're inspired to do that. Really starts with our customers, though. We want to make sure that we're bringing solutions that our customers want. But in doing that, we are employing some of the most innovative technologies and the innovative minds and the creative minds. And so I think that's where the Edison Awards comes in, to really recognize how you approach a problem and the innovations that you can bring to the market in order to solve those problems in innovative ways. So we have a pipeline, and I know that we're going to be there in next year and for the years to come.
Well, we'll be excited to learn more about those innovations in the coming years.
Yeah.
Thank you for sharing that with us.
Yeah.
Carlonda, it's been a pleasure to have you on Inspiring Minds. Thank you for talking about innovation with us and sharing Kennametal's great innovations that are happening.
Thank you.
You've been listening to Inspiring Minds, powered by the Edison Awards, showcasing leading innovators from across the globe. I'm Jennifer Trammell. Thank you for tuning in, and we look forward to having you join us for our next conversation with another inspiring innovator.